Welcome back to exercise 2b, simplifying surds. Now, before we start, I'm just going to look at a couple of rules. Now, in maths we often have rules or laws that tell us what to do, and with surds we're going to look at three main ones today. So, rule 1. Rule 1 states that square root of a all squared, make that look like a squared, is equal to a. That's because the square root sign and the square are the inverse of each other. They're sort of cancelling each other out. Similarly, if I have a squared and the square root, that is also equal to a. This rule is also important when we look at multiplying the same number under the surd, because we would also just get that number. All right, rule 2. Rule 2 states that if I have the square root of a multiplied by the square root of b, I get the square root of a b. Now, if I sort of break that up a little bit, I'll do an example. If I have the square root of 3 multiplied by the square root of 2, that is actually equal to the square root of 3 times 2, which is equal to the square root of 6. So there's our second rule. And so I'm just going to move these down a little bit, so I've got some room for rule 3. Actually, if you're looking for an example, in rule 1, we could look at the square root of 3 squared. That would be equal to just 3. Or if I had the square root of 3 times the square root of 3, that would also be equal to 3. All right, rule 3. Now these rules are important to follow, as they'll help you answer the questions in 2b. The next one states square root of a divided by the square root of b, and a and b just represent any letter, is the same as saying the square root of a over the square root of b. Or we can take it further, they can actually be under the same house, a over b. All right, so we can look to simplify. An example of this, square root of 15 divided by the square root of 3, square root of 15 all over the square root of 3. Well, that's the same as saying the square root of 15 divided by 3. We know that 15 divided by 3 is 5, so we have the square root of 5. Now, you'll get better at seeing how these rules are working and be able to move a little bit quicker. But if you need to, make sure you add in all your steps. All right, example 6. It states that the square root of 6 all squared. And it says to evaluate, it means we want an answer. You can actually put this one in a calculator and it'll give you an answer. But it's important to recognise that this is rule 1. And if I have the square root and the squared acting at the same time, they create the inverse of each other, and I would be left with the number 6. All right, let's have a look at example B. 2 square root 6 all squared. In this example, we have a number out the front here, a whole number, and we have a surd part. Just remember that this squared belongs to the number out the front, and it also belongs to the square root of 6 here. So if I was to break this up, I would end up with 2 squared multiplied by the square root of 6 squared. Notice I said the 2 belongs to both, so if I was to complete this, I would have 2 squared, which is 4. Now the same rule as the one above. Square root and a squared would create the whole number 6, and we'd be left with 24. All right, now we're on to example 7. Question A. It relates to rule 2, which states, when I multiply two surds together, I can put them under the same house and simplify. So we have the square root of 3 multiplied by the square root of 11, and that would equal the square root of 3 times 11, which is equal to the square root of 33. B, if you've looked ahead, is already so we have division this time, rule 3. I always like to make them look like a fraction. You might have seen that we've done this one. And that is equal to the square root of 15 divided by 3. If you are unsure, as I said, you could put them under the same house to do your simplification. All right, example C. Notice they've already written it in fraction form. So you could put them under the same house if that's going to help you. 42 divided by 6. Now they are both divisible by 6. That would leave 7. That would leave 1. 7 on 1 is just 7, so our answer would be the square root of 7. You can go from the question straight down to the answer here and avoid that step. But as I said, if you're just sort of in an amber light, meaning orange light, you're sort of unsure, add in the extra step. Last question here, also division. We have the square root of 35 divided by the square root of 10. This is a classic example of where you might like to put them under the same house to help you simplify. Now when we're looking at the fraction part, both numbers are divisible by 5. 35 divided by 5 is 7. 10 divided by 5 is 2. And I'm going to continue that this is the square root of 7 on 2, or you could say the square root of 7 on the square root of 2. Give them separate houses again to finish off. All right, example 8. Example 8's multiplication again. And what you'll recognise here is that we can actually multiply the number parts, the whole numbers together. And if the work was available, we can multiply the surds together. So if we look here, we have 3 multiplied by 7 square root 5. In this case, we can multiply our whole numbers together. We'd have 3 times 7 is 21 square root 5. There is a time sign here, but we don't need to write that. But just remember, we can multiply the whole numbers together. B. 9 times the square root of 2 times 4. Now they've just moved the order around here. I can still multiply the whole numbers together. 9 multiplied by 4 is 36 times the square root of 2. If you just missed that, I could also write this as the same as saying 4 times 9 times the square root of 2, because the order in times doesn't matter. And once again, I could multiply the whole numbers together and the square root of 2. All right. Rule 2 is going to be important for question 9 because we sort of work backwards. We've got them under the same house and we actually want to split them up. In this example, we're really going to need our square numbers. So 1 squared is 1, 2, 4, sorry, not 2. 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49, 64, 81, and 100. Now, when we're simplifying a surd, we want the highest square number to go into that surd. So the square root of 18. And I'm looking for the highest. Apologies here. Square root of 18. I'm looking for the highest square number that might go in. And in this case, it's 9 that goes in neatly. And I'm going to write this as the square root of 9 multiplied by 2. Still the value of 18, and simplifying, we're not changing the amount, we're just changing how it looks. And if I give them their own house, the square root of 9 times the square root of 2, you can actually find by using the square number, the square root of 9 is a whole number. It is 3. So 3 times the square root of 2. And I've simplified that surd there. B, square root of 108. Now this is a good case of we want the highest one to go in. Now I can tell you that 9 goes in, but I'm not sure it's the highest. Now if I start, I can check out 100. It doesn't go in evenly. 81 doesn't. If you're unsure, you can always check. You put it in, 108. And you can divide by 64. As you'll see, it's a decimal. And you can keep checking this. 108 divided by 49. Doesn't go in evenly. Let's try the next one. 108 divided by 36. And you'll notice it goes in 3 times. So we write our square number first, then its other factor. We're going to put them in their same houses. And because we've used a square number, it can become the whole number times the surd. And you've simplified that surd. Working backwards in 11. Now, we actually simplify them in 9 a little bit more often. But in 11, if the number is out the front, and it's asking us to put it back inside as a whole number, what we need to do is to work a little bit backwards. Now, to come out the front, we've done the square root. So to put it back underneath, we actually need to square it. 3 squared is 9, so I get 9 times 7, and as a whole number, that would be the square root of 63. So to put the 3 back under, we needed to square it. It actually relates to rule 1. Question B here, 5 square root 3. Now, as I said, to get it back under the square root sign, we have to apply squared. Only to the 5 because we're moving it back underneath. Now, if we write this out, this is 25 times 3. And to give it as one single whole number, 25 times 3 is 75. And we've made it as one whole number. So it's just the 9 and 10 are the reverse of each other. Well, I'm going to pause the video here. Example 11 I'm going to do in a second video later.